In the next two problems, we're going to keep working with finding exact trig values given circles and points on those circles. So in this next problem, given the circle and the coordinate points in the form x, y, determine the exact values of each of the following. Now, let's keep in mind, remember, secant is the reciprocal of cosine, so that would be 1 over cosine of beta. And since cosine, we talked about in our last problem, was the same as x over r when we're dealing with our unit circle, secant could be thought of as r over x. And so looking at our sort of circle here, I like to actually sort of draw in that horizontal and vertical distance and sort of label the pieces here. So we're looking at a radius length of 3. Our vertical distance is that negative 2.24. and our horizontal distance would be negative 2. So in this case, we would have 3 over negative 2 as our secant of beta value. Now, cosecant, remember, is the reciprocal of 1 over sine of beta, which another way of writing that would be r over y, since we're looking at our vertical distance here. So in this case, we would have 3 over negative 2.24. And last but not least, cotangent, which is the reciprocal of tangent, would end up being x over y. And so in this case, we would end up with negative 2 over negative 2.24. But since they're both negative, it would end up actually being positive, which makes sense since we've talked about that the slope of the terminal right in quadrant 3 should end up being positive. Now, in part D, we're asked to find the value of b. In this particular case, our inverse function, it's not going to help to have, we're not going to be able to get exactly to the angle in quadrant 3 without using some symmetry or reference angles. I personally like to change these back into their sine or cosine values before using the inverse, though if you are using Desmos, Desmos does have inverse of our reciprocal functions, but knowing that secant is negative 3/2, I know that cosine of beta would be negative 2/3. And so since I know that, I'm going to go through and do arc cosine. Oops, if I spelled cosine, arc cosine right. Arc cosine of negative 2/3, and that comes out to approximately 2.3. And so that would be a measure in quadrant 2 here. And I'm looking for the measure, though, of the angle in quadrant 3. But sort of that mirror image angle would be the same. So if I simply find 2 pi minus that angle measure, I would come up with 3.983 radians as the measure of angle beta, which is the same thing as about 228 degrees. All right, the next problem is a little different. So we're given a circle, but instead of giving it a point, we're actually given the arc length here. So that 20.5 inches of the angle that's cut off, the arc cut off by angle A. And we're asked to determine the following values, and we're told that we can round if we would like. So this requires us to remember, if you remember sort of arc length, arc length was equal to, the angle measure times the radius length. So if I'm looking for the radius length, if I'm looking for the angle measure, I can simply take the arc length and divide it by the radius length, which in this case is 4. And so that angle is actually approximately 5.125, not approximately, exactly, radians. And I'm going to leave my angle measure in radians. Now, since I'm not actually asked to find exact values here, this is now just a matter of putting these into my graphing calculator and coming out with values. So for cotangent, I would do cotangent of and that radian measure. And if we are dealing with Desmos, which I hope you are using, you should be able to just use all of these trig functions. They're all right here. So we have cotangent, and we can type 5.125. And then I can do the same thing for oops, but I should make sure I'm in the right mode. I'm in the wrong mode. Now I'm in the right mode. I was like, that's not the right value. Then I can do cosecant of 5.125. Oops. Again, I'm having some difficulty typing. All right, so we got the decimal in there now. Okay, I'm liking that. A negative sign value, a negative reciprocal of sine. And then we have secant of 5.125, and I know that one should come out positive because it's the reciprocal of cosine. And last but not least, the tangent value. And so I have all of these 4 values. I just found them. I'm putting them in the calculator. I have been asked to approximate and round each of the values. So I do not need to keep them exact. This was just sort of an exercise in, did I find the angle measures? Was I then able to get the correct values for each of these? And then I am asked a follow-up question for that last tangent of alpha. Can we interpret what the value represents in the context of the problem? And so in the case of this particular situation, the terminal ray that is swept out 5.125 radians from the 3 o'clock initial ray has a slope of negative 2.284. And that would be sort of the interpretation of this particular tangent expression.